Why is there always stuff out in this lab? Oh, okay, I might as well play with it a little bit. What is this? NaCl and lauric acid. Hey, Mr. Park, how you doing?
Good, I was just standing here.
Didn't see you. So it looks like somebody came in, some elf came in overnight and set up a bunch of tests for us to do. And they want us to look at salt and lauric acid. Table salt, NaCl, and lauric acid. Thought we could test a few things. What should we test first?
Let's do salt.
Okay, what are we gonna look at with salt?
I don't know, why don't you put some on that glass plate there?
This watch glass?
A watch glass,
Some
yes.
people call it an elephant contact lens, but... Okay. So let's describe this a little bit. It looks like it's little crystals. It's not a powder, it's more of a crystal. Let me just, oh yeah, that's crunchy. It's very brittle. Yeah, definitely crunchy, hard crystal form. You can see it jumping around. Cool. All right, so that's salt. Let's do a little lauric acid. Oh, I can already see a slight difference. It's still white, but I don't see crystals as much as I see like flakes. They're almost like flat, yeah, flat flakes.
They seem pretty soft.
Yeah, it's definitely breaking up. It's powderizing a lot easier than the salt. You can hear it too. It's not all crunchy. The salt was all crunchy. So I'd say this is a flaky, soft substance, and the salt was a more of a brittle, hard substance.
Cool.
Man, things are quite a buzz here in the chemistry lab. What's that buzzing noise?
That's the gas valve that you're hearing right now. It's because we're using the Bunsen burner.
Gotcha.
So we've got a hot water bath here, and...
Time for 0 hour. That's all right, we'll leave it.
Okay. So I want to see if we can melt these two solids, right? We just tested their hardness. And so what I'm gonna do is I'm gonna take salt.
Oh, look at you, you're reusing it.
That's right, I don't wanna waste it.
Absolutely.
So we've got our salt here in the test tube.
Uh-huh.
And I'm just gonna place this
Oh, that's dangerous.
in the hot water bath.
Did that burn at all?
No, it's far enough above it. I'm gonna do the same thing with the lauric acid.
Kind of hard to see with the curvature of the beaker what's going on.
Well, here, I can pull it out closer here if you want. See the salt in there, the solid?
Still a solid, huh?
Still solid.
Okay. Maybe it hasn't been in there long enough.
And I don't need this as high right now. All right, so here's the lauric acid.
Okay.
And we have black markings at the top of this so that we can tell the difference.
So the lauric acid's in the black marked test tube.
That's
Got
right,
it.
it's in the black test tube.
Okay, let's see what happens when we put that
So I'm
in.
just gonna lower this in here. And let's give it maybe a minute.
Dun, 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 dun.
Ooh, actually, I can see the changes already. If I bring this closer to the side of the beaker,
Oh yeah,
solid doesn't look so solid anymore.
gotcha. What does the salt look like? It's been in there long.
All right, let's take a look. The salt is still a solid.
Nothing melted?
No change.
Okay, I think that's pretty conclusive then. The salt's been in there. Whoa!
And lauric acid is mostly melted.
Did you pour water in there?
No, I only left it in there for a minute.
Wow.
So I bet we can get it completely melted if we just put it in there for a few more seconds.
So boiling water boils at sea level at about 100 degrees Celsius. So
this definitely melted. The lauric acid definitely melted. And I don't know the exact melting point. I just know that it melted somewhere below 100 degrees. 100 degrees or below.
So on that same rationale, then we'd say that salt must have a melting point above 100 degrees.
That's right.
Okay, thank you. Okay, so for this part of the experiment, we're going to test solubility. Now, solubility is whether a substance will dissolve in another substance. Specifically, whether these solids will dissolve in the liquid solvent that we're going to use. So if you look here, we've got this set up. The first test we're going to do is the left side of this test tube rack. Both solids are going to be dissolved, or we're going to try to dissolve each of them into water as our solvent. Water. Now, water is a polar solvent, something we'll talk about in class. So we're going to put salt and lauric acid in the test tubes. You notice we have rubber stoppers to close them off. We'll make sure we explain why just a little bit. We're going to take some salt, put it in. Notice I'm going to use a different spatula now for the lauric acid. You never want to cross-contaminate. Okay. So, on your right is still the lauric acid.
That's our left.
Sorry, your left. Sorry, I'll change it. So on your right is the lauric acid, and on your left is the salt. Now we're going to mix this. We're going to do something called inversion, mixing by inverting. We're not going to shake it really hard because that could be dangerous. So I'm just going to mix these a few times equally. And on your left is the salt. Hopefully you can clearly see that it looks like, I don't see any more solid in there.
I see lots of bubbles, and it kind of gives it an opaque appearance,
Right.
but there's no
murky.
solid chunks in there anymore.
Right. If you look at the lauric acid, there is still a bunch of the solid floating on top. And there's little pieces of little particulate matter of the solid floating around inside, but it doesn't appear like anything really disappeared. You can see up top there's still a bunch of it. I'll shake it a few more times.
You mean invert it?
Invert it, thank you. Yes. Mixed by inversion. How are my bingo arms? Good?
I don't know what that means.
Bingo!
I still don't know what that means.
You know, yeah, it's okay. Okay, so it's pretty clear.
Yeah.
Or not clear in terms of what it looks
The
like.
lauric acid did not dissolve. The chunks are floating,
Yeah.
but it didn't dissolve.
And the salt.
Salt completely dissolved.
Okay. Good. So now we're going to look at the same two solids dissolved into hexane.
What's hexane?
Now, hexane is a molecule that we say is completely nonpolar. Okay, now we're going to learn in class what polar and nonpolar mean, but water was a polar solvent. Hexane is a nonpolar solvent. So we're going to see if the polarity of our solvent matters in the dissolving process. So here is salt, which is an ionic compound. Oh, thank you. Appreciate that. Here's salt, which is an ionic compound. I'm going to put it into lauric acid. Again, new spatula, or the same spatula from lauric acid before. I'm going to put that into the hexane. We'll stopper these up. Okay. Again, salt's on your left. I didn't screw up this time. Lauric acid is on your right. So the bingo comment, Mr. Park, when the old ladies go play bingo and they get a bingo, they go, bingo! And their arms kind of flap. So I was wondering if I had bingo arms going on.
Okay.
All right. So it's a little harder to see. Here's the salt. But you can see there's still salt grains. The crystals are all along the side there. And there is, I don't know if you can see underneath.
Yep. They're still
There's
sitting
salt
at the
crystals.
bottom.
They're sitting at the bottom. So it appears like the salt is not really wanting to dissolve. It's still all in there. Okay? But here's the lauric acid, and there is not a trace of any solid in there.
Nope, all the lauric acid is dissolved.
So it appears like the results are the exact opposite in the nonpolar hexane. I'm sneaking up on Mr. Park here in his natural habitat. In a dark room. Whoa, whoa. Hey, Mr. Park, what are you doing over there? What are you doing?
Nothing. I mean, I am testing conductivity.
Conductivity?
So you know how we were investigating lauric acid and sodium chloride?
Mm-hmm.
Well, I wanted to see what would happen with a conductivity tester. So
That's what this is?
This is a form of a conductivity tester, yeah. And so you see it's got a light bulb attached to these two electrodes.
Cool.
And it has to be hooked up to a power source. So
And how do you know if it's conducting?
Well, because it's a light bulb, if the electricity gets sent in from one end, if the electricity is able to conduct through the liquid and reach the other end, then we know that it conducts.
So if you just touch those electrodes together, the light bulb will light up, but we're not going to touch them. We're going to see if the solution can link them.
Right.
Okay. Let me turn the lights down.
Here's the lab you guys will be spending some time with. Pretty exciting. Like that, or you want to go all off? All off? Okay.
Whoever set this lab up probably shouldn't have put the tester right below a light bulb, but that's okay. We'll talk to him later. All right, what do you got here?
So the speaker contains hexane, which we looked at earlier, and it has dissolved lauric acid.
Gotcha.
That's why you don't see any, because remember how we said lauric acid dissolves in hexane?
Was there a watch glass on top of it too?
Yeah, the watch glass was because hexane evaporates really easily, and so by putting this on here, it slows down how much evaporation takes place.
Gotcha.
I don't want
So
the
I would
room-
take it that hexane must be kind of dangerous if it's in vapor form.
It's actually flammable. Yeah, it's a little brother to
Gotcha.
gasoline.
Okay, so we're plugged in. We're gonna stick this. This is lauric acid in hexane, and you have the electrodes in the liquid. And I don't see anything in the light bulb.
No,
No
there's
result.
No conductivity.
Okay. I'm gonna unplug this, Mr. Parks, so you can wipe off. Mr. Parks is gonna wipe off the electrodes. We always want to wipe off the electrodes. You should think about why we would do that. We're not gonna tell you why, but there's a question in your lab that might reference that.
All right.
Okay.
So this is salt, sodium chloride in hexane. Now, you just like before, you can see that the sodium chloride did not dissolve in the hexane.
Okay.
Okay. So let's test if this solution conducts.
Okay, same thing. I see the electrodes in there, and the filament in the bulb is not lighting up at all.
Nope, no conductivity.
Okay. Let me unplug this. Safety first. Good, good. All right, plugged back in.
Okay. So now,
These don't have watch glasses on them anymore.
you know, that's just because this is water and water doesn't evaporate as quickly.
Gotcha.
So you can see the floating chunks of lauric acid, how they didn't dissolve. They're just floating at the top.
All right, so this is lauric acid in water. Man, this is getting kind of boring. Oh, results are results, I guess.
Not much here.
No, nothing. Okay. Hang on, let me hold it. Let me unplug. There you go. So it doesn't look like this stuff. Maybe solutions don't conduct. Maybe liquids don't conduct electricity.
Maybe.
What's our last one?
This is sodium chloride dissolved in water.
Okay, it's still got a little bit of a murky.
Yeah,
but
that's a little cloudy.
It's definitely a clear solution or colorless solution. Okay, here we go. Oh, wow! Look at that. That's almost as bright as if you plugged it straight in.
That has a lot of conductivity.
That's great. I also heard it when you first put it in. I heard it. There's a bit of a shock there. Let me zoom in here.
You can actually see the
Whoa,
electrolysis taking
that is
place.
cool.
Yeah.
So on the electrodes, we can actually see bubbles. What that is that's actually electrolysis. That's the water. Because there's so much conductivity and electrical current, we're breaking the bonds in the water molecule and we're separating hydrogen from oxygen. That's really cool. So to recap, what did we see?
Well, the only solution that conducted was sodium chloride in water.
So the ionic solid in water.
Right.
Got it.
Mr. Tro, what are you doing?
Nothing. I was just cleaning up the lab. There's glass. We're everywhere. I don't know who teaches in here. How you doing, buddy?
Okay.
It's fine. No?
I see we still have the sodium chloride and lauric acid left out.
Yeah. I just didn't get around to cleaning it up yet. I think we're done with the lab, right?
I think we have one more test.
What's that?
The aroma test.
Why would anyone ever want to smell this stuff?
Well, sometimes smelling chemicals can give you some insight as to what they are.
Okay. So should I just open it up and just take a whiff?
Well, I don't know if I would do it that strongly. Maybe you might want to waft the air first.
Waft the air.
That's right.
Got it. Okay, so this is salt, NaCl. We're going to, as Mr. Park said, waft the air.
Smell anything?
I mean, I smell a little bit of plastic, but that's the bottle it's in. No?
Okay.
Not really. Nothing. I mean, it's salt.
Well, maybe you can't identify salt by smelling it then.
Okay. Lauric acid.
Try it.
Oh, yeah, actually, I get definite. The closer I get, too. There's a definite smell there. It actually kind of stings the nose a little bit.
They use lauric acid in bar soap.
You know, it does smell kind of fresh. It also reminds me a little bit, it's kind of weird, but it reminds me a little bit of like crayons. Smells kind of like Crayola crayons.
Waxy.
Yeah. But definitely has an aroma.
Okay. And so what type of bonding does lauric acid have?
I believe we know that lauric acid is covalent bonding and that salt is ionic. So I guess I'm a little confused on why we're looking at aroma.
Well, maybe the bond types are maybe one is stronger than the other, and if one is stronger than the other, then the molecules can't leave each other.
Because because if we smell it, somehow those molecules have to be going into our nose.
They have to be leaving and floating in the air.
Got it. So to smell a substance, some of the molecules have to escape the solid and get into the air so we can smell it.
Right.
Got it. That makes more sense. Okay, so salt had pretty much no smell. Lauric acid had a definite strong odor.